So we're going to have a look at a few questions from exercise 13.4, starting with question 2. So part 1, we need to make x the subject of ln x, take away ln x subscript 0 equals kt. Now, it's important to note that x0 is just a constant. We could have used the letter P or Z or whatever, or any other kind of different letter. It is just another way of labelling a constant. So treat it as you would any other constant, so any other letter that's not a variable. So first thing we can do, and there are different ways of going about this, but this is an efficient way of doing it, is to apply our rules of logarithms here. So ln x subtract ln x0, that's ln of x over x0, and that is equal to kt. We now need to try and isolate x, which means we want to get rid of the ln on the left-hand side. So I'm going to take e to the power of both sides. Now, if you want to, you can write in this step here, e to the ln of x over x0 equals e to the power of kt. And then on the left-hand side, the e to the power of ln cancels out, leaving you with x over x0 equals e to the kt. You can, of course, go directly from this line down to this line here. Now, all that remains to be done is multiply both sides by x0, which gives you x equals x0 e to the kt. And we are done. So part 2, we are given s equals s0 e to the negative kt, and this time we have to make t the subject of this formula. Now you can, if you want to, start by taking ln of both sides. I think it's slightly easier to actually divide by s0 first of all. So s over s0 equals e to the negative kt. Now we're going to take ln of both sides, so I'm going to write ln of s over s0 equals ln of e to the negative kt. Now on the right hand side, ln of e cancels, remember they're inverse functions of each other, and you're left with negative kt. On the left hand side you still have ln of s over s0, and remember again we could have gone straight from the second line to here, taking ln of both sides. I've written up the line above this just to give you a really clear idea of what's happening. Now the last step is to make t the subject, so I'm going to divide both sides by negative k, so I end up with negative 1 over k ln of s over s0 equals t. In theory you can split up that ln of s over s0 as two separate parts like that. I think that makes the answer slightly messier if you do that, but it would be a valid step if you wanted to do it. Now in the answers you will notice that the final answer for t looks slightly different because they've done a final stage of manipulation here. So let's just work through this. What they've done is take this negative here and use it as a power. So they've done that. So they've moved the negative up to the power. They've left the 1 over k alone, which is fine, and it's the negative that then makes its way up as a power of negative 1. On the right hand side we still have t. Now we know if something is raised to the power of negative 1, that is a reciprocal. So this then gives a final answer of 1 over k ln s0 over s equals t. And that's the answer in the back of the textbook. Part 3, we have to make p the subject of this result here. So first step is to take e to the power of both sides. On the left-hand side, the e to the power of ln p over 25 will cancel in a minute. On the right-hand side, e to the negative 0.02t. Now on the left-hand side, we will simply end up with p over 25. Like so. And remember, as I keep saying, you can go straight from this line to this line without having to use the step above. This then allows us to do a final step of rearranging, multiply by 25, and this gives us p equals 25 e to the negative 0.02t, and we are done. Part 4, we now have to make x the subject of this result over here. So I'm going to simply start off by dividing both sides by y minus y0, which leaves me with e to the x on the right hand side. Then simply I want to take ln of both sides, so I've got ln of y minus 5 over y minus y0 equals x, and we have finished. Some people might like to split up the left hand side and write it as ln of y minus 5 take away ln of y minus 0, but I think it's actually a lot neater as it is in this format here. Question 4. We are asked to find the coordinates of the point on the curve y equals e to the negative 2x, where the gradient, i.e. dy by dx, is equal to negative 1. So the first job is to differentiate this. Now, in a previous lesson, you will have looked at the fact that if y equals ke to the ax, where k and a are constants, i.e. they represent numerical values, if you differentiate this, dy by dx will equal ake to the ax. And as I keep saying, you will learn about this in much more detail in year 13 when you study the differentiation techniques in the second year of the A level. So differentiating this result here, dy by dx, we will get negative 2e to the negative 2x. So they want us to find out which x coordinates on the curve result in a gradient of negative 1. So let's set the gradient equal to negative 1. Now from here, let's divide both sides by negative 2, which gives us e to the negative 2x equals 0.5, and then we have to take the natural log of both sides, so negative 2x equals ln of 0.5, divide by negative 2, so x is equal to negative a half of ln of a half. And if you work that out on a calculator, that gives you an x value of 0.3465, etc. So 0.347 to 3SF. Now take your exact value of x, i.e. this value over here, and substitute that back into the original equation, which will give you a value for y of 0.5. Now that should make perfect sense because you are working out y equals e to the power of negative 2, and then if you sub in your x value here, that's negative a half ln of, well, let's call it 0.5 for simplicity. So that is e to the power of ln 0.5, and the e and the ln cancel here, giving you a y coordinate of 0.5. So question 6, we are given the formula v equals 8 plus 22e to the negative 0.07t. So this is a formula that tells us velocity or speed of a parachutist after they've jumped out of an aircraft versus time t. Now the first thing we have to do is sketch the graph. So if t is equal to 0, you can very quickly work out that v is equal to 30. So we can plot a y-intercept. We know the graph is an e to the negative exponential function, so that gives us an idea of the shape. And then we know as t approaches infinity, so as t gets larger and larger, e to the negative 0.07t will approach 0, so we can see that the velocity or the speed will approach 8. So there's an asymptote at v equals 8, and the graph will look like that, approaching this asymptote. You can check this on your calculator. Part 2, state the speed of the parachutist when the parachute opens, and the final speed that she would attain if she jumped from a very great height. So we're told that the speed at time t seconds from when the parachute opens is given by this formula. So when the parachute opens, that is when t equals 0. That's when we start measuring the speed of the parachutist, and at t equals 0, as we've just said, v is equal to 30 meters per second. So find the final speed that she would attain if she jumped from a very great height. Well, the final speed that she would attain, well, you can see that is this asymptotic value over here. The graph is approaching this as t approaches infinity. So as time increases, the velocity approaches a value of 8 meters per second. The idea being that if she jumped from a very great height, there would be sufficient time for her to reach this speed. So part 3, find the value of v as the parachutist lands 60 seconds later. So that's t equals 60, so we need to substitute in v. So that is 8 plus 22 e to the negative 0.07 times by 60, and that gives us a value of, this is 8.329 ... meters per second, so 8.33 meters per second to 3 significant figures. And part 4, find the value of t when the parachutist is travelling at 20 meters per second. So v equals 20, so we have 20 equals 8 plus 22 e to the negative 0.07 t. We have to solve this equation. Subtract 8, so we have 12 equals 22 e to the negative 0.07 t. Divide by 22, so 12 over 22 equals e to the negative 0.07 t. Take natural log of both sides, ln, so 12 over 22 equals negative 0.07 t, and then the last step is of course to divide through by negative 0.07 to find a value of t. This gives me a value of t equals 8.6590 ... so 8.66 seconds to 3 significant figures.